Welcome back, everyone. Before the break, we reminded ourselves about the definition of volume. We also defined the volume of certain polyhedrons, and a reminder that a polyhedron is a three-dimensional figure. So, in this part of the lesson, we are going to actually be working through some examples of volume. Let's look at the first one together. So, we have been asked to determine the volume of this specific figure. If we have a look, we can see that we have a rectangular pyramid. Just a reminder that we define the volume of a rectangular pyramid to be 1/3 times the area of the base multiplied by the perpendicular height. So, let us get going with this calculation. So let us just write the definition for the volume of a rectangular pyramid again. The volume is equal to 1/3 times the area of the base multiplied by the perpendicular height. So first things first, everybody, I need to know what the area of my base is. Well, what is my base? It is a rectangular-based pyramid. So this means that my pyramid base is a rectangle. And how am I going to calculate the area of this rectangle? Well, I know the area of a rectangle can be found by saying length times breadth. So we're going to have 5 times 2. So far, the volume of this figure is going to be equal to 5 times 2. We then know that it is going to be multiplied by my perpendicular height. In this case, please note that I actually have been given the perpendicular height. I've been given this right angle. In the next example we're going to do just now, we're going to see what actually happens when you're given the slant height. But because I have been given the perpendicular height, it means I can substitute it straight into my formula. So I'm going to have 1/3 times 5 times 2 multiplied by the perpendicular height of 13. I'm going to simplify my brackets. So I'm going to have 1/3 times 10 times 13. So I'm going to have 1/3 of 130. Now we are going to substitute this into our calculator. So we've got 1/3 being multiplied by 130. And that's going to give me 43,333. So we can see the 3's recurring. If I round to the second decimal place, I'm going to have 43,33 centimeters cubed. I just want to make another note about the units being cubed, just in case you've only just joined us now. Please remember that the units for volume are always cubed. For area and surface area, the units are squared, but because volume refers to the capacity that a three-dimensional shape can hold, the units will always be cubed. So just want to highlight that and just make sure that I remind you of that for examples when doing measurement. Great, let's go back to the board. My next example is asking me to determine the volume of this specific figure. Now, you might say, well, ma'am, this looks very similar to the example I just did. But there is a difference. The main difference is that we have not been given the perpendicular height. We have been given the slant height. So 13 meters is my slant height, and this is going to be an issue for me. Also, something that I do want to note is that it is actually going to be 13 centimeters for the height. I don't know why it says meters. That is a typo. I'm going to ask you to calculate it with 13 centimeters, please. Great. So let's go into the calculation. I'm just going to correct the typo. We want it to be 13 centimeters, please, everybody. Great. So if I'm going to determine the volume of the figure, it's going to be 1/3 times the area of my base multiplied by my perpendicular height. The area of my base is going to be the area of my rectangle, which is my base that is given over here, which is 12 centimeters by 10 centimeters. So the volume is equal to 1/3 times the area of my base, which is 10 times 12. And this is going to be multiplied by my perpendicular height. But I do not have my perpendicular height yet. I only have my slant height, which is 13 centimeters, and I do not have essentially AG. I want to know what AG is, because AG is my perpendicular height. The question is, how am I actually going to find AG? I'm hoping that everyone's going to have a bit of a think at home on if there's any way that I can actually find AG. Well, we are looking at an example of Pythagoras, because we've got a right-angled triangle within this specific pyramid, because we can see that the perpendicular height will be AG, FG will be my base, and I can see that my hypotenuse is in fact 13 centimeters. So if I'm going to be calculating my perpendicular height, we can say that AG squared will be equal to 13 squared, because that's my hypotenuse squared, minus 5 squared. And the reason why I'm saying minus 5 squared is because FG is half of 10 centimeters. So the base is going to be 5 centimeters, because we know that the perpendicular height will occur in the middle of the rectangle. So if the perpendicular height's in the middle of the rectangle, that means that FG will be half of CB. So if I do Pythagoras, I'm going to have that AG squared is equal to 169 minus 25, which means that AG squared will be equal to 144, which means that AG is equal to 12 units. So just a note, please make sure over here that you write Pythagoras' name in brackets, because we always have to give him credit for his working. So my perpendicular height is actually in fact 12 centimeters. So let's plug this all into the calculator to find out what the volume of this triangular pyramid is. Rectangular pyramid, sorry guys. So we're going to have 1/3 multiplied by 10 times 12 times 12. So we can see that this rectangular pyramid has a volume of 480 centimeters cubed. Again, just a reminder, I've said cubed because it is the volume calculation. Let's go to the next example, everyone. So I have now been asked to determine the volume of this specific cone. What have I been given? I've been given my radius, and I've been given my slant height. So again, everyone, I'm going to remind you that it's very important that I know what type of height I have been given. I've given you the slant height, but for volume calculations, I need the perpendicular height. So I'm going to ask you, if I want the perpendicular height and I've been given the radius and the slant height, is there a way for me to get the perpendicular height? Great, so if I look at my cone, I've got the right angle triangle present, and I'm going to use Pythagoras to find my perpendicular height. So the perpendicular height squared will be equal to the hypotenuse squared minus the radius squared. So we always say the hypotenuse minus one of the sides squared, and this is because of Pythagoras. Now, to find out what an expression for h squared, I'm going to use my calculator. Great, so I have 25 squared minus 7 squared, which is going to give me 576. 576. Then if I square root that, it's going to give me 24. So I'm going to have a perpendicular height of 24. So I can now fill in the information for my volume. So I've got a third pi multiplied by my radius squared multiplied by my perpendicular height, which I found using Pythagoras. So we know that this is 24 centimeters. Let us plug this into our calculator. So it's a third multiplied by pi multiplied by 7 squared multiplied by 24, which is going to give me 392 pi. And if I want to round this off to the second decimal place, we're going to press our SD button. So it's going to give me 1,231,50. And I'm saying centimeters cubed because it is a volume calculation. So the volume of this specific cone is 1,231,5 centimeters cubed. Great, everyone. I hope that you're still with me. Let us go on to our next example. So we are now going to be determining the volume of a sphere that has a diameter of 17 centimeters. Now, I'm hoping that everyone's immediately got little alarm bells going off in their head. The second I see the word diameter, I have to remember that I'm often needing to use my radius in calculations for volume. So because I've got the diameter, it should be almost like a little bit of a clue that there has to be a step that comes to find the radius before I actually find the volume of the three-dimensional shape. So let's go to the board together and see what I mean by saying that. So the volume of a sphere is 4/3 pi times r cubed. And because it is multiplied by r cubed, I have to address the fact that I've been given a diameter of 17 centimeters. If I substitute in 17 in the place of r, my volume is going to be so much larger than it needs to be, everyone. So please make sure that you first write down what your radius is. And I know that my radius is always my diameter divided by 2. So what is my radius? It is going to be 8,5 centimeters. This is good news because now I can actually substitute into my formula. So it's going to be 4/3 pi multiplied by 8,5 cubed. Let's get our calculator. Great, so it's going to be 4/3 pi multiplied by 8.5 cubed, which is going to give me 4913/6 pi. And if I want to write this correct to the second decimal place, I'm going to press my SD button, which is going to give me 2572,44. And please remember that I have to include my units. And my units will be centimeters cubed. So the volume of the sphere is 2,572,44 centimeters cubed. Great, everyone. I hope that you've enjoyed our lesson on volume today. I really hope to see you again sometime soon.